Welcome to Rutgers Center for Vector Biology information website. This presentation of calibrating New Jersey light traps is part of the New Jersey Adult Mosquito Surveillance Program's preparation for the mosquito season. New Jersey County mosquito control agencies are all urged to maintain their New Jersey light traps through inspection and airspeed calibration such that the trap results can be compared throughout the state. This presentation is in two parts. Part 1 is the maintenance of trap mechanics, and Part 2 is the calibration of the trap, as well as how to calibrate a handheld anemometer that you may wish to use in the future. We'll start out listing the items you'll need to calibrate your New Jersey light traps. We'll then go through the calibration procedure, including the use of the dial anemometer. We'll finish up by showing how to calibrate a handheld anemometer by using the center's dial anemometer. Items that you'll need for the complete cleaning and calibration of your light trap include a data sheet and pencil. This data sheet should list the date of cleaning and calibration, trap identification number, location of where the trap will go, the general condition of the trap such as wires and killing jar, and a section on the airspeed calibrations. You can download the Excel sheet that we've been using here at the center from the video page. Calibrations will also require a stopwatch, anemometer, and stand to place the traps on. A resting box or large pail is of an appropriate size to place the trap on upside down. An electrical source to supply power to the trap and aluminum foil to cover any light sensors are also necessary. Calibration is an important feature for New Jersey light traps. Because these traps are standardized for the amount of air flowing through the traps, we can compare trap catches from one year to the next, as well as catches from one site to another. These comparisons, particularly from year to year, are an important element of assessing mosquito populations for the purposes of control. As such, calibrations should be performed each year prior to the beginning of the mosquito season. The primary instrument in the calibration of the light trap is the use of a dial anemometer. This particular anemometer can be obtained from Davis Instruments. These 8-blade anemometers are extremely reliable and will work for many years. A holder will have to be manufactured for fitting the anemometer onto the light trap. New Jersey County mosquito control agencies can borrow the Center for Vector Biology's dial anemometer. This anemometer has an on-off switch at the side of the dial casing, as well as a reset switch just off from the face of the anemometer. To take a reading, make sure that the anemometer is set to 0. Count down using a stopwatch, turn on the anemometer, and let it run for 1 minute. At 60 seconds, turn off the anemometer and take a reading. To take a reading, you need to understand the face of the anemometer. There are 2 small subdials, plus 1 large dial encompassing the face. The 2 subdials are in thousands and 100s RPM, while reading the large dial is in tens, with single digits shown as line gradations. This particular meter, thousands, hundreds, tens. Okay. This particular meter is reading at about 404 RPMs. Note that the 1000 subdial has moved partially between 0 and 1000. After each reading, remember to reset the meter back to 0. These adjustments are provided by the manufacturer of the dial anemometer and are important primarily for reading under 1445 or for readings above 1745. That's because at those readings your light trap may be out of the appropriate range of 1440 to 1700 RPMs. Average your adjusted readings, and if your light trap is properly running, the average will fall between 1440 and 1700 RPMs. But what happens if these readings are out of range? If your reading is above 1700 RPM by less than 1000 RPMs, you should probably do nothing. That is because through the season the motor will run slower and readings will decline. You generally see high readings from a light trap whose motor has recently been replaced. If the gap is very large, you should probably replace the motor and check to see if it is running at the appropriate wattage, amperage, and RPMs. If the average is below 1440 RPMs, you should change the motor. Don't try to adjust the speed of your motor by bending the motor blades. This will only increase vibrations in the traps and may damage the trap. If you need to get a new motor, replace the one with the same type of motor currently in the light trap. For Hauscher and BioQuip traps, this is a GE 4-watt 0.27 amp 1550 RPM motor. For Hawk traps, this is an A.O. Smith 4-watt 0.29 amp 1550 RPM motor. If you have a handheld anemometer, you can calibrate it to the dial anemometer to determine the values of the lower and upper limits of a correctly running trap. To do this, you should sample several traps with both your handheld and the dial anemometer. Take a minute reading with the dial anemometer, write that value down, adjust it with the correction factor, and remove the anemometer. Place your handheld anemometer such that it is between the struts of the funnel located inside this trap. Make sure you place your anemometer perpendicular to the trap and that your fan is fully inside the trap. This is the position you will want to use for your handheld in the future. Take the reading when the reading is constant. Remember, this is an instantaneous reading rather than a cumulative one as with the dial anemometer. Do 3 readings from at least 3 traps. You can also do single readings from each anemometer with at least 5 traps. The more traps you read from, the more precise your line will be. Once you have your readings, you can plot your results in Excel. An example can be seen here with the data from the dial anemometer and the handheld in the 2 right columns. Plot as a scatter plot, and then by right-clicking your mouse on the data, select Add a Trend Line. Add the linear trend line and make sure you check the Display Equation on Chart and Display R-squared value on chart options. This will give you the information you need to find the precise upper and lower limits, plus how confident you can be in your handheld. Once your line is visible, you can go from the x-axis at the lower and upper limits to find your handheld anemometer values. Here at 1440, over to the y-axis will show your Kestrel values. You may need to extend the line to include the 1700 value. Once you're it will be more precise to use the equation, and this is the equation on the previous example is y equals 0.00023 times x minus 1.3116. To find the lower limits, the x is replaced with a 1440, and that calculates to 2.00 rounded down. The upper value is found by substituting x with 1700, and this value calculates out to 2.60 rounded up. So this particular handheld kestrel anemometer will show values between 2.00 and 2.60 for properly calibrated light traps. Note that these handhelds can be showing instantaneous readings rather than the cumulative readings as mentioned before. If you can set a handheld to a cumulative reading, you should be able to get values with a wider range and thus be more accurate. So, in summary, calibrating light traps are an important part and procedure of the maintenance of your traps. Calibrating allows comparisons to be made from year to year and from different sites. And calibrating your own handheld anemometer gives you flexibility in maintaining your light traps throughout the season. We hope these two presentations of the maintenance and calibration of light traps will provide you with clean and calibrated traps through the mosquito season. Thank you.